Evaluate integral from 0 to 2n pi, maximum of the sin x and sine inverse of sin x dx, where n belongs to the integer. Since we know that the graph of sin x is like this, like a wave with a time period of 2 pi, after every 2 pi interval the graph repeats itself, and sine inverse of sin x graph is like this, kind of a wave but in a straight manner. This function is also periodic and repeats itself after a time period of 2 pi. So both sin x and sine inverse of sin x are periodic function with a time period of 2 pi. I is equal to n times from 0 to 2 pi, and rest of the things are pretty same. Here we write n because initially we want to find the integral from 0 to 2n pi, but we know the nature of sin x and sine inverse of sin x is periodic with a time period of 2 pi. So we want to evaluate the integral from 0 to 2 pi, and we will multiply it by n to get the integral for n times. So we evaluate the maximum of these two functions from 0 to 2 pi and multiply it with n. So eventually the result will be the integral from 0 to 2n pi. This is the fundamental property of definite integration. Now let's combine both these graphs, and then we can find easily what's the maximum of both the graphs. So we combine both the graphs from 0 to 2 pi and we get this kind of figure, where this blue graph represents sine inverse of sin x and this gray kind of graph represents the sin x, and we want to find the maximum here. So clearly I can see that for 0 to pi, maximum value will be of this graph, which is blue, that is this sine inverse of sin x, and from pi to 2 pi the graph of sin x will be maximum for the negative values of the y coordinates. So the value of integral will be I is equal to n times, because n was already there. First of all, let's find the area from 0 to pi. From 0 to pi we can clearly see this is a kind of triangle, and the area of this triangle is nothing but half into base into height, which is half into pi by 2, because from 0 to pi the base is pi and the maximum value here is pi by 2. From 0 to pi the maximum values of this function, which is sine inverse of sin x, and it forms a triangle, and the area is half into base into height, that means half into pi by 2. And from pi to 2 pi the maximum value is of sin x. That means we can get the maximum of this sine curve only. Because for negative y-axis only sin x will be the maximum. So from pi to 2 pi only sin x will give us the maximum value. So if I integrate from pi to 2 pi sin x, on evaluating we get minus cos x, limits from pi to 2 pi. Eventually this becomes minus of cos of 2 pi minus cos of pi. and on solving we get minus of cos 2 pi is 1 minus cos pi is minus 1, and it becomes minus 2. Now using these two values from 0 to pi, the maximum is sine inverse of sine x graph, which represents this triangle, and the area of this triangle is this half into pi by 2, and from pi to 2 pi the maximum is this sine curve, and the value of this sine curve is minus 2. Finally integral becomes n into half into pi by 2 plus integral of sine curve is minus 2, and upon solving we get n into pi square upon 4 minus 2, and finally I becomes n into pi square minus 8 by 4. Here this half into pi by 2 represents the area of this triangle from 0 to pi, and this minus 2 represents the area of this sine curve from pi to 2 pi. And if we evaluate it for 2 and pi intervals, we just multiply here by n, and we get the required answer.